Welcome to myprojectbazaar.com. Now we discuss about title of the project. Our project title is a predictive cross-layered inferences management in a multi-channel Mac with a reactive routing in VANET. Let us discuss about the abstract of our project. A mobile ad hoc network. MANETs are networks that are created on the fly, that is ad hoc between the various mobile nodes and do not require infrastructure. The mobile nodes can move around and the network would automatically reconfigure itself to allow a connectivity. The vehicular ad hoc network or subclass of a MANET that is expected to have a key roles in the intelligent transportation system of the future. The VANET provide vehicle-to-vehicle communication and vehicle-to-roadside communication in order to provide support in the safety, comfort applications. And despite being a subclass of a MANET to VANET having a fundamental difference behavior. In this process, the availability of a different communication channels is considered in order to improving the system performance. In a distributed multi-hop architecture, a mobile nodes may potentially finding the multi-hop routers for all the destination. When evaluating network topological through its routing table, and in the considered case, the availability of the different availability channels protocol may enhancing the community quality. In this process, a new inferences aware routing protocol for VANET environment is provided. Let us discuss about the objective of our project. To minimizing the end-to-end delay in the transmission, to improving the confidentiality and reliability, to proposing an idea is mainly based on the cross-layer approaches to managing the inferences in a MANET context. This project is proposed in NS2 simulation. Let us discuss about flow of our project. First one is a network formation. The node deployment is the first module of this project. The mobile nodes are to be deployed. The nodes are formed with a given range of sensors. Nodes are grouped automatically depends upon their radio waves. Agents are formed for a group registration. The simulation is done in NS2 simulation. The simulation model, there are 37 nodes are deployed in 2000 cross 2000 meters cut field. All the nodes are set as a static nodes and that is a mobile communication. The routing protocol which is used in this simulation. Next one is a neighbor discovery. On-demand reactive routing protocol that using the routing tables with the entire per destination. When a source nodes need to finding the routing to the destination, it starts a route discovery process based on the flooding and to locating their destination node. Upon receiving a node request, the packet intermediate nodes update their routing tables for receiving route to the source. Similarly, the forwarded route to the destination is updated upon the reception of a routing replay. The packet oriented either by the destination itself or any other intermediate nodes that has a currently routing to the destination. If the neighbor node is finds, means it will go for a routing multi-hop routing. Otherwise, it will find a neighbor discovery. The multi-hop routing is used in the proposed method for constructing an optimal path for transmitting the sensed data to the destination. The nodes which has the data to transmitting, it's called a source node. Such the node check for a next best hop to transmitting the sensed data toward the destination. For finding the next best hop, route request messages is sent to all the neighbors. The routing request is sent to all the intermediate nodes between the source and the destination. We proposing a simple energy aware local geographical routing with avoiding the avoidance algorithm. The basic idea is that a node selection of the neighbor which is close to the destination as a next hop. In this protocol, the packet header containing the packet sequence number which begins with a 1 and increasing 1 for a new generating packet. The combining of the source ID and the and the packet sequence number called a packet ID. Unique IDs are unique identifying a packet. In addition, each node maintaining the routing table which containing the source node ID, packet sequence number, and next best hop and the node ID. Next one is a communication. Here the V2R communication. V2R is nothing but the vehicle to roadside communication. The vehicle to vehicle communication is done. Then the analysis. Simulation result eliminating the efficiency of the proposed system compared to an algorithm developed for the sensor network. Finally, we compared the performance of the existing and the proposed system. The parameters such as the throughput, packet delivery ratio, and delay are also compared. Let us discuss about the output of our project. First, open the terminal window. Now change the directory. Our project code directory is root. So type cd space routing. Now change the directory root into routing. Then type ns space main.tcl. This command is used to run our ns file. Now run the process. This is NAM console. This is our.NAM window. This is our network formation model. This is zoom in button. This is zoom out button. Rewind button. Play backward button. This is stop button. This is forced play forward button and forced forward button. Now I play the project. This is the blue color nodes indicate the vehicle nodes and the black color line indicates a road. Then the brown color node indicates the RSU. Then this is test authority. Then this is a police station and base station. Now start routing. This is routing path. To detect error, send the communication. Now sends communication. 12th node sends communication to 13th node. So now road to vehicle communication is done, and vehicle to roadside communication is done. All the routing path covers the any RSU. The RSU provide the routing. The road to road communication and the road to vehicle communication is done. Now we discuss about the performance of our project. So type xgraph space thr.xg. This command is used to display our throughput of our project. Then xgraph space pdr.xg. This command is used to display packet delivery ratio graph. The routing table is displayed here. The routing table contains node, current timing, destination node ID, next hop, number of hops between the source and destination, sequence number, expire date, and a flag value. Thank you for listening. Now our demo is completed.